There's a formula for differentiating from first principles, and here it is. I'm just going to talk briefly about where it comes from because I think it helps with understanding, especially understanding what differentiation is. So I'm going to say I've got some sort of function. Here it is. And I'm going to consider 2 points on this function. First point is going to be where I have x, and therefore the y coordinate is f of x. Second coordinate is x plus h, a little bit further along, and I'm going to control how much further along it is. So h is kind of, yeah, I can make it big, I can make it small. And this is going to be f of x plus h. So I want to find the gradient between these 2 points. So the run is just going to be h, and then the rise is going to be the difference. It's going to be f of x plus h minus f of x. And then the change in y over the change in x is going to be this rise over run. So f of x plus h minus f of x all over h. And this is where the idea of differentiation comes in, the idea of a limit. So what we're going to do is move this point closer and closer to this other point, and we can control it until they're basically in the same place. And that means we're going to let h approach 0. And in that limit, you get this dy by dx, the instantaneous gradient or the derivative. So in this question, you don't need to know all that, but I think it helps to see where it comes from. Just remind you, what we need to be able to do is implement this formula in the case that f of x is 2x cubed plus 3x. Now, the good news about this question is that we even know the answer, and even if it said differentiate from first principles, like we could use the rule to get 6x squared plus 3. Okay, so we know we're correct if we manage to get that at the end, pretty much. Right, I've got f of x, so next up I'm going to find f of x plus h. So that is going to be 2 times x plus h cubed plus 3 times x plus h. Now we can just expand this as a triple bracket, or we can kind of use Pascal's triangle and do it really quickly. So for x cubed, it's these terms here. And I'm going to get 2 times x cubed plus, then the coefficient is, next coefficient is 3. 3h x squared plus 3h squared x plus h cubed plus 3x plus h. If you want to do it by just expanding it, sometimes I do that to be fair, then of course go ahead and you should get the same thing once you collect your terms. I'm not going to go through that here, but you should get this and then bring it down. Then I'm going to do a little bit more with it, I think. Just expand it. So 2x cubed plus 6h x squared plus 6h squared x plus 2h cubed plus 3x plus 3h. All right, and now we can find f dash x. So f dash x is therefore going to equal the limit as h approaches 0 of all of this. So I will write it down. I'm going to just realize I'm going to run out of space, so I'm going to delete this. But because it's a show that question, don't rush it. Show the terms cancelling. So I'm going to minus the f of x, which is minus 2x cubed plus 3x inside a bracket. So then it's going to become minus 3x all over h. This cancels with this, and the 3x cancels like that. Yeah, just write this out again. I'm going to factorize the h out, I think, at this point. There's a common factor of h, so 6x squared plus 6hx plus 2h squared plus 3. all over h. And these also cancel. You could alternatively just cancel one of them out in each of these when we're adding them, but this is fine as well. And then as h tends to 0, this term is going to disappear because, yeah, h is getting as small as I want it to, and this one is as well. And so I'm going to simply be left with 6x squared plus 3. I don't think we need to say any more than that. I could maybe by the side say 6hx and 2h squared tend to 0 as h tends to 0. But that is it. Pretty comprehensive. Nice one.